Okay, students, we're going to look at our last lesson in Chapter 4 today, so 4.4, called Polygons in the Coordinate Plane. So we're going to be talking about some new things that hopefully you've seen in elementary school. So our learning target today is going to say, I can draw polygons in the coordinate plane and find lengths of sides. I can draw polygons in the coordinate plane and find lengths of sides. So the first thing I want to talk about is this word polygons. I've briefly touched on this, but a polygon is just any closed shape, and we've talked a lot about triangles and trapezoids and parallelograms. All of those are examples of polygons. We do need to do a little bit of work with what coordinate plane is, so we'll talk about that first. But go ahead and pause the video and get your book set up to page 176 first. Make sure that you're all set with that. So at the top of page 176, it says you can use ordered pairs to represent vertices of polygons. To draw a polygon in a coordinate plane, plot and connect the ordered pairs. There's a lot of words in there, so we're going to talk about coordinate plane first. So I'm going to have us list that word as some vocabulary. And when we draw a coordinate plane, usually, especially when you get up into the higher math classes, it's drawn like this, and there are 4 different sections of a coordinate plane, and these are all called quadrants. So this quadrant right here is quadrant number 1. This quadrant is quadrant number 2. Then this is going to be quadrant number 3, and this is quadrant number 4. And today we're focusing on quadrant number 1, so we're only looking at this section of our coordinate plane because all of these numbers in this section are going to be positive numbers, and we haven't discussed negative numbers yet. So we're going to be looking at quadrant 1 today. So if we zoomed in on this coordinate plane and only looked at this quadrant, it would look like this. Wow, let's try that again. If you have a grid journal, little squares in your journal, that's when this is going to come in handy here for this type of lesson. If you do not have a grid journal, then you should still be able to do this work. It just might be a little harder to make your lines completely straight. So here's quadrant 1 on the coordinate plane, and we're going to label a couple of special things. This center right here in the middle is called the origin. So that would be this right here, this point right here. We're going to label that origin. And the numbers that attach to the origin are 0, 0. So the origin is always at 0. This line down here, and that's similar to this line here, we call that the x-axis. This is my x-axis, so I'll label that on this one too. And then this line that goes up here, which means it goes all the way up this side, that's going to be our y-axis. And I'll label it over here too. So we have these 2 lines, our x-axis and our y-axis. And then when we have an ordered pair, I'll list one more word up here. An ordered pair is listed in parentheses with a comma in between the 2 numbers. So this 0, 0 over here is called an ordered pair. And when I put in my numbers, the first number is going to be the number that represents what we did on the x-axis, so how we went over this way. And the second number is what we do on the y-axis, so that represents what we do up this direction. So we go over first, and then we go up. So with all of that being said, we can go ahead and talk a little bit about our work for this lesson with polygons. So if we take a look over back at 176, it says drawing a polygon in a coordinate plane. The vertices of a quadrilateral are A, 2, 4, B, 3, 9, C, 7, 8, and D, 8, 1. Draw the quadrilateral in a coordinate plane. So for example 1, we'll switch colors here so we can see this as an example. I'm going to draw the same coordinate plane that I've done up here. So we'll write example 1. We'll draw out our y-axis, and we'll draw out our x-axis, and we'll be able to plot these ordered pairs. So we're going to list our ordered pairs in example 1 over here. So A, they told us, is going to be at 2, 4. B is going to be at 3, 9. C is going to be at 7, 8. And D is going to be at 8, 1. And the directions say draw the quadrilateral in a coordinate plane. We know it's going to be a quadrilateral, quad meaning 4, because there are 4 different ordered pairs. These are going to be our vertices, or the corners of our shape. So when I'm trying to plot A, 2, 4, I always start right here at the 0, 0, the origin. And remember, the first number is how much I go over, and the second number is how much I go up. So I'm going to go over 2 lines, and then I'm going to go up 4 lines. That spot right there is going to be our A. So I'm going to label it A after I put a dot there. Next, I'm going to plot 3, 9. So from the middle, or the 0, I'm going to go over 1, 2, 3 lines and go up 9 lines. It looks like my graph's going to extend a little bit up into my vocabulary. So I've gone over 3 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm way up here. Hopefully you did a better job of spacing out your ordered pair. This is our B. So my quadrilateral will overlap my notes up top just a tiny bit. Our C is at 7, 8. So over 7, 1, 2, 3, 4, 5, 6, 7, and up 8. 1, 2, 3, 4, 5, 6, 7, 8. So here is our C. And our last one is 8, 1. So back to the 0. And I go 1, 2, 3, 4, 5, 6, 7, 8. And up 1. So I have to extend my x-axis just a little bit. And that's our D. So now we can connect our 4 dots as best you can. Use a ruler if you can. With this program, I can't really use a ruler, but there we go. Here is my quadrilateral, my 4-sided shape, and it looks kind of like a trapezoid here. It's kind of a shift over trapezoid, but that's what we've got. So we drew the quadrilateral in the coordinate plane. So that is example 1. If you'd like to pause the video and try the on your owns, they just have 4 problems there and they want you to draw the quadrilaterals. So there's nothing really I can do in terms of telling you what the answers are. They would have to be shown in pictures. So if you want to check your answers, you can go ahead and bring these on your owns into class tomorrow and I'll take a look if you'd like me to, or you can just get an extra practice of plotting those coordinates. Either way, let's shift on to our next example. 177, it says finding a perimeter. So it says the vertices of a rectangle are 1, 6, 7, 6, 7, 2, and 1, 2. Draw the rectangle in the coordinate plane and find its perimeter. So it's similar to the last one, but there's one added step they're asking us to do, which is finding the perimeter. I'm going to do a better job of thinking ahead here. Looking at our numbers, I've got to go up to 7 and up to 6 there, so I'm going to do a better job of drawing my coordinate plane so that I've got some more space so I don't go up into my next example. So the quadrilateral they give us, we have an F, which stands for 1, 6. They give us a G, which stands for 7, 6. They give us an H, which stands for 7, 2. And they give us a J, which stands for 1, 2. So we're going to start the same way. We're going to always put our pencil in this corner to begin as we try to plot these points. So 1, 6, I'm going to go over 1 and up 6. And that's going to be my first location, and I'm going to put an F on that. Then I have 7, 6, so back to my 0. 1, 2, 3, 4, 5, 6, 7. Notice I'm counting the lines. How many lines have I traveled, or how many full boxes have I traveled? 1, 2, 3, 4, 5, 6, 7 boxes, and 1, 2, 3, 4, 5, 6 boxes. So that's going to be my G. My H from the 0 is 7, 2. So over 1, 2, 3, 4, 5, 6, 7. Let's try that again. 1, 2, 3, 4, 5, 6, 7. Oh, it looks like I have plotted my G incorrectly. So we're going to get rid of that guy. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. This is where my G should be. And 7, 2 is going to be right here. Here's my H. Then I have 1, 2, so over 1 and up 2. If I connect my lines this time, you can notice that we ended up drawing a rectangle. Our corners have 90 degrees and the two sets of parallel sides. So 90-degree corners, so it's a rectangle. So now I'm going to find my perimeter. Remember, perimeter is when you add up the sides. So I have to know what the sides are first. So if I'm going to figure out the distance from F to G, I have to figure out how many whole boxes long is this line. And I can see it's 1, 2, 3, 4, 5, 6 whole boxes long, which means this one is also 6 whole boxes long. Then on the sides here, I have 1, 2, 3, 4 whole boxes long. So this also has to be a 4. So if I add up my sides, I have 6 plus 4 plus 6 plus 4. If I add up all of those numbers together, I end up with 6 and 6 making 12, 4 and 4 making 8. So I have a total of 20. Now we don't have an actual unit to label this, so we're just going to say units. Perimeter, we just label with the units. Remember, area, we put a little 2 on it, but for this one, we're just going to go 20 units. And I've completed example 2. We have one more example today, so I'll switch colors. So for example 3, it's a real-life application. It says, in a grid of the exhibits at a zoo, the vertices of the giraffe exhibit are 0, 90, 60, 90, 130, and 0, 30. The coordinates are measured in feet. What is the area of the giraffe exhibit? So I'm going to list the coordinates, but we can look at the picture of the exhibit in the book. So if you're looking at your book on page 177, you can see that they've already plotted for us those coordinates. So we have E at 0, 90, and then we have F is at 60, 90, and then we have G at 100, 30, and then we have H at 0, 30. And instead of drawing this entire picture on an actual grid to make it a little easier, we can just draw kind of a rough sketch of what this shape looks like on the grid. So we have a line going down, a line going across. This bottom one is a little longer, and then it comes down like this. So we end up having a trapezoid here, and this is for a giraffe exhibit, so I'll also label that too. That's an awful E. Okay, so this is my giraffe exhibit shape. It looks like a trapezoid, and the corners, the E, F, G, and H, are here. And so they want us here to find the area. That's what we're trying to do. So we're going to have to use the formula we learned earlier on in this chapter for area of a trapezoid. But in order to do that, we need to find the two base numbers, and we need to find the height number. So if we take a look at our numbers, E was at 0,90. So we're at 0,90 here, and then F is at 60,90. So from the 0 to the 60, from 0 to 60, we've increased by 60. So I know that this is a 60 units long. And then this one from H to G, if I look at H, which starts at 0 here, and G, which starts at 100, I know that this is 100 units long. And then this height right here from H to E, H starts at the 30, and then it goes all the way up to the 90. So from 30 to 90, if we subtract 90, take away 30, that's going to be 60 units long as well. So if I use my trapezoid formula, I'm going to add up my bases and multiply it by the height. So my height is 60. Then I'm going to add up 100 plus 60 in the parentheses. And then I have to divide all of that by 2. So 100 plus 60 is 160. Then I have to multiply that by 60 on the outside. And then on my calculator, I can take all of that answer and divide by 2. If I do that, I end up getting 4,800. And if I look back at my question, it looks like these measurements are in feet. So we're going to put feet. And since we are finding area, we'll put feet squared. So I get 4,800 feet squared when I do 100 plus 60 times 60 and then divide it by 2. And that brings us to the end of our lesson. If you'd like to try the on your owns at the bottom of 177, you can go ahead and pause the video and do that. So for number 5, that's just basically drawing the picture, but then the answer to the question, what's the perimeter and the area? The perimeter is 15 units and the area is 11 units squared. And then for number 6, the what if question, how does this affect the area? Increases the area by 600 feet squared for a total of 5,400 feet squared. And that brings us to the end of our last lesson in chapter 4.